0 volt, 5 volt, 10 volt. So it is controlling the voltage, it is regulating the voltage perfectly. 3.3 volt. The voltage are stable now. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session, we will build a DC power supply with regulated voltage option. In this first step, we will regulate the voltage. And in next part, we will control its current. We will continue step by step. I will use LM324 IC. I will use PNP transistor 2SA1941 and I will use 2SD195 Darlington transistor with high gain. I will use two potentiometers 50K and 5K, coarse voltage adjustment and fine voltage adjustment. Let's make this circuit. In initial step, I will use two type of voltage. One, high voltage that we want to regulate. The second, VCC voltage for LM324. In upcoming session, we will regulate same voltage as a VCC voltage for this IC. But for this time, I will use 28 volt positive. I will apply to transistor. We will take output. (1941) PNP transistor. It is 10 ampere continuous current. If you are designing at 5 ampere, take 150% for safe margin and select any PNP transistor or anyone available with you. I will use heatsink compound for its better thermal conductivity. I will not use any PCB. I will build this circuit on this cardboard. Emitter, base and center pin collector. I will use 12 volt power supply to power up this LM324. Pin number 4 positive, pin number 11 ground. 5K, 50K. Pin number 4 of this IC, positive supply. It will reach to potentiometer this end. Pin number 11. I connected two potentiometers. This end positive, 5K, 50K. This end ground. This point will reach to pin number 3. That is non-inverting input. Basically, we are creating non-inverting amplifier. Pin number 3, non-inverting input. This is positive supply. This is negative supply. We will connect to pin number 3. We will apply 12 volt signal to this operational amplifier and we will take 12 volt output for this transistor, and we will bring feedback from the output side. We will not inject feedback from pin number 1, we will inject feedback from output terminal. I will use 330 ohm resistor at the base of this transistor. Here is base. I will connect 330 ohm resistor on the base. D195 is a special transistor, Darlington transistor. If you cannot find it, that time you can use NPN transistors, 2 NPN transistors, 1 signal transistor and 1 medium power transistor in Darlington pair. Base emitter will be connected to ground, 330 ohm resistor, and it will reach to pin number 1 of this 324 IC. That is output of first stage. And here we will connect 10K resistor at base, 10K 1 watt, D195, and we will connect 470 ohm resistor, and we will connect to collector. This is 10K. It is pull down resistor for the base, 9.87K. Emitter base. .470 ohm resistor, 470 ohm resistor at base, 468.3 ohm. We will connect this resistor at base pin. It is drive signal. This time I am using 330 ohm resistor. When we will use current control, that time we will replace it with 10K depending on the signal size. We will connect this wire to the collector pin because collector is output. This is output. I connected a capacitor here, 1000 microfarad, 35 volt, and this end is grounded. Input ground, that is here. Ground for this power supply and ground for this power supply. All grounds will common. We will connect this ground to the emitter of this transistor. This ground is connected here. When this transistor will turn on, it will allow current from emitter to collector, this resistor and this path. It will change the base biasing of this transistor, so this transistor will conduct and it will allow voltage in the output side. We will connect this ground to this IC. And I will connect a dummy load resistor across this capacitor, 1K 0.5 watt. This resistor will discharge this capacitor when we are decreasing the voltage. It will work as a bleeder resistor. Now I will connect 12 volt positive here at pin number 4. These 12 volt positive will reach to this potentiometer. This ground will reach to potentiometer this side. We will adjust this coarse adjustment, fine adjustment, and we will receive signal at non-inverting input. I will connect positive voltage which we are going to control at emitter pin. I am using positive 26 volt, 28 volt. You can use 30 volts because our control circuit is operated with 12 volt and we are controlling high voltage by this transistor, this input power supply ground. It is high voltage input line. In my case I am applying 28 volt, 26 volt, 28 volt, and this 12 volt separate. Maybe in upcoming session I will use transformer. We will use just only one 30 volt, 40 volt transformer. We will regulate the voltage for this IC, 7812 IC. Now we need feedback. Input voltage are 26 volts. This time no output because we don't have any control signal. The feedback is missing now. We need feedback. 26 volt and maximum amplitude of control signal is 12 volt. So we will consider 12 volt. We need 12 volt feedback at inverting pin so that this IC will control the voltage. Output line, we need a voltage divider network. 26 volt output. If I use 10K resistor here, 10K, I need 12 volt. I need 12 volt V over R, 12 divided by 10,000, 1.2 milliampere current. Remaining 16 volt divided by 0.0012, 13.33K. I will use 15K, that will good. 15K, 10K. $15K high side, 10K low side. Ten K resistor will be connected to ground side. Center node will go to pin number 2 as a feedback. This is feedback signal. It will help this circuit to control the voltage. Any operational amplifier needs two signals. The one inverting input, the second non-inverting input. Based on these two signals, this IC will provide control signal. We are using this IC in single supply operational amplifier mode. If we want to control dual power supply, that time we need dual signal. Now our circuit is almost complete. Inverting input. I will connect load. If you are new to my channel, you can subscribe it. And if you are enjoying this video, you can hit the like button. We connected input voltage here, that are 28 volt, 26 volt, to the transistor emitter. Here is 10K resistor that is connected to base. Base is controlled by collector of this transistor. So emitter of this transistor is connected to ground. This current will control the base conduction of this transistor. So it will work as a linear potentiometer. This IC will receive 12 volt at pin number 4. 11 is grounded. Pin number 3 is non-inverting. We are using just only one section to control the voltage. In next session, we will control its current. Let's apply voltage. Zero volt output. 0.747. The motor is not turning on because this time this motor is 24 volt motor. The voltage are stable now. Yes, the motor started now. 3.192. It is course adjustment. If I will adjust this potentiometer, it will adjust in millivolt. .3 volt. Let's adjust it at 10 volt. We will adjust course range from here and fine adjustment from this potentiometer. Fantastic. If you enjoyed this video, give a thumb up. 15 volt. .24. Because our input voltage 26 volt and same 26 is now 25.98, that is at output. If I control the voltage, we can see the voltage are dropping at this capacitor. Zero volt, 5 volt, volt. So it is controlling the voltage, it is regulating the voltage perfectly. Let's adjust at 18 volt. You can also use LM324 IC. If you think this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.